acidic nature and acidic strength of carboxylic acids. So this is lecture 3 of carboxylic acids. We were discussing carboxylic acids preparations. In this class, we will go with carboxylic acid properties. About this, so many examples are already there in my YouTube channel, you can check. Here I am giving you few more in a row. Carboxylic acids, acidic strength and acidic nature. On what factors it is going to depend. This line we are going to discuss. So, are you ready? Sure. Carboxylic acids dissociate in water to give a resonance stabilized carboxylate ions. The meaning of this is acid, carboxylic acid. It is giving you one proton to this H2O, so it is becoming H3O plus, and this part is RCOO minus. RC double bond O, single bond O minus charge. It can participate in resonance, so that you can see here RC O minus and double bond O. So the resonance hybrid is RC, negative charge can be on both these, so we show like this. This is resonance hybrid. So here RCOOH, when treated with water, it gives you RCOO minus and H3O plus. So if you are writing as dissociation constant Ka, acid dissociation constant. Acid dissociation constant is written like equilibrium constant because here also equilibrium is established as this is a weak acid. So what happens here? RCOO minus and H3O plus. RCOH. Concentration of products by concentration of reactants. Water we are not taking because water will be excess in quantity and its concentration won't change. RCOO minus H3O plus divided by RCOH concentration, where Ka is called acid dissociation constant. So here you remember two lines. Ka value when it is high, when pKa value is low, that is strong acid. What is pKa? pKa is equal to minus of log Ka. When Ka is high, pKa is low, that is strong acid. Similarly for bases, you can remember the same line. Kb is high, pKb is low, that is strong base. Not required here, just I am giving you a point of ionic equilibrium. Ka high, pKa low, strong acid. Reverse, if you take Ka low, pKa high, weak acid. So that point you can remember. Here few lines about these. Effect of substituents on the acidity of carboxylic acids. What are the effects? See, electron withdrawing groups minus I, or you say minus M, these are good. Increase the acidity of carboxylic acids by stabilizing the carboxylate ion. This is important line. How they can stabilize the carboxylate ion? See, C double bond O and O minus we are, if some NO2 group type of groups are present here, these are electron withdrawing groups. When electron withdrawing groups are there, the negative charge on this carbon or the overall negative charge can be decreased. When the negative charge is decreasing means that is becoming more stable. So this is the point you need to remember. Okay, we will be showing the same thing. The conjugate base through the delocalization of negative charge by inductive effect, or you say resonance effect. Inductive effect or resonance effect. See here, this is this side, when the electrons are going out, stabilizes carboxylate ion. So you can take a fluorine, chlorine, NO2 group, cyanide group, all withdrawing groups you can take here. So electron withdrawing groups directly proportional to acidic strength. Remember this line. On the other hand, electron donating groups decreases the acidic nature or acidity of the carboxylic acids. As they can't stabilize the conjugate base, they are going to destabilize the conjugate base by providing these electrons. Already negative charge is here. ऊपर से और भी नेगेटिव चार्ज आप भेज रहे हो, नेगेटिव चार्ज है बोल के ये परेशान है, ऊपर से आप और भी नेगेटिव चार्ज दे रहे हो, सो इट बिकम्स लेस स्टेबल, destabilized by such kind of groups like OCH3, OH, NH2. Directly lone pair containing groups are decreasing the acidic nature. Increasing number of chlorine atoms. Okay, now example is given chlorine. You can take fluorine, bromine, iodine, anything is fine. Which cause minus A effect, increases the acidic strength. See here, this is COH group, immediate position, alpha position. You can say 3 chlorines are there. Here 2 chlorines are there. Here 1 chlorine is there. Here no chlorines are there. More the number of. Okay, now for example, Br3CCOH, Br2CHCOH, BrCH2COH, CH3COH. This is the case. Okay, now more the number of minus I groups, much is the acidic nature. Then coming to this point, increase in the distance of chlorine atoms or bromine atoms or iodine atoms is simply minus I groups. Minus I group atoms from COH group decreases the acidic strength. Very close is best. You see, this is COH alpha position, this is COH beta position, ये COH है, ये गामा पोजिशन हो गया. जब इलेक्ट्रॉन विड्रॉइंग ग्रुप्स है तो नज़दीक रहना चाहिए. ओके ना, दिस इज क्लोज, so this is more acidic than this. When electron withdrawing groups are there, they must be close. Okay, this point is to be noted. Increase in electronegativity of the halogen atom increases the acidity. For example, you see fluorine, chlorine, bromine, iodine. You can say this is minus I order. Fluorine is stronger minus I group than chlorine, than bromine, than iodine. Stronger the minus I group, higher is the acidic nature. Fluorine is stronger than chlorine, than bromine, than iodine. Increase in the electronegativity of halogen increases the acidity. Okay, this point is to be noted. If the COH group is in bond with unsaturated carbon, acidic strength increases. Very simple, because of this double bond or triple bond, the stability will be more of the carboxylate ion conjugate base, so that is more acidic. Okay, now compared to this is more better. Compared to this is much better. Electron withdrawing group on C6H5 of aromatic carboxylic acid. Aromatic carboxylic acid is nothing but, you can simply say, benzoic acid. So this is benzoic acid, you can say. In this, if you are means if the compound is having OCH3 type of groups or OH or NH2, all these at para position, these are all electron releasing groups, so they are not required. Decreases the acidic nature. In place of that, if NO2, Cl, Br or Cn type of groups are present, all these are electron withdrawing groups. They are best. You can see here NO2 group is present here, OCH3 group is present here. NO2 group is much better, much better. This is more stronger acid. This is because of plus I, this is because of minus I. Increasing order of acidic strength when the carboxylic acid contains these group, you can see phenyl group, then iodine, bromine, chlorine, fluorine, all these are minus I groups. Fluorine is stronger, just now you are seeing the same lecture. Then cyanide, then NO2, then CF3. CF3 is the strongest one. So if CF3 is there, that is a better acid. Then NO2, then Cn, then FClBri. Decreasing order of acidic strength is given, you see CF3 group is present here, then CCl3, then CHCl2, then Br, then HCOH, then ClCH2, C6H5, CCH5CH2COH, and CH2CH2COH. Okay, because here CF3 group is there, here CCl3 group is there, and here 2 chlorines only present, here only 1 chlorine is present, here bromine is present, here 1 carbon is missing, if I am not wrong. This should be little longer, because BrCH2COH, ClCH2COH, Cl is stronger, but you take here 1 carbon extra. Fine, जो थोड़ा गलती हो गया चेक कर लो सर. You can see here CF3, CCl3, CHCl2, NO2, NC. You see 3 fluorines are there. 3 chlorines, 2 chlorines, 1 NO2 group, 1 cyanide, 1 fluorine, 1 chlorine, 1 bromine, no groups, formic acid, then chlorine. This is, you see, C6H4COH means it is not like this, ClCH2CH2 C6H4COH. It is like benzoic acid. This is benzoic acid. Then CH2, CH2Cl, C6H5CH2COH, CH2COH, and finally this one. No need to remember this order as it is. They will be asking you by giving 4 compounds. Okay, now you must be able to say this one. Next session we will go with ortho effect. Next lecture, don't forget to see ortho effect. Okay. If you like this video, tell me. If you have any doubts, you just mention me. I will try to clear all your doubts. Thank you.